Welcome to this Wednesday webinar. Today we'll be covering multi-cutter roughing and automatic pre-drilling in rough. My name is Andy Strombeck. I work in technical support at Cimatron North America. Multi-cutter roughing showed up in version 16. It gives you the ability to rough with one procedure but with multiple cutters. It works in rough, spiral, parallel, and volume pockets. Cutters must be the same diameter and shape, but the holders can be different. The side step can vary, but not the vertical step. Let's go ahead and take a look at this. So we'll start with a basic file here. We'll go ahead and just see how this gets set up. Fairly standard part with some pockets here, nothing too fancy yet. I do have it set up how I normally would. I have part, it's already on its own set. My cover faces, those are on their own set. So just part of my file setup that is organized already. Let's go ahead and grab a roughing template here that has most of the settings I would normally use. My stock and my target part, I'll go ahead and run those. Let's take a look at this rough. So I have a cutter in here that I would machine with. My surfaces are picked, my tool trajectory is set, and then under entry and endpoint, this is the only thing I need to make sure of. We have some choices. Right now it's set to no plunge. For showing the multi-cutter rough, I'm going to go ahead and leave this on optimized, set it to 1 degree. So we have one tool that's going to come in and rough this all out. All right. So when we look at this, we can see, hey, there's quite a bit of material left behind here. It didn't get cut all the way out. And we can make more procedures and we can step down the tool size and keep doing that. But really, what we're going to go with is the multi-cutter. We'll come down to the cutters and holders, and we will check the box to use multiple cutters. When I do that, I can come back to my cutter selection, and I'm allowed to pick through other tooling that is the same diameter and the same shape. So I'm going to send these other two cutters over. Green check. And you can see if we decided we wanted a variable side step, we can turn that on and we can enter the value in a minimum step. We won't do that for this, but simply enabling additional cutters, selecting them, and now we calculate. All right, now when we look at this stock, we can see with one procedure and one tool, we now have all the material removed in that one procedure. It's pretty handy. And one way we can identify this besides simulation, I'll switch to wireframe here. We can highlight the procedure, go to NC Edit, Other, divide procedure by cutter change. Now we can break these up, assign a different color, and we can see the different tool usage when we get in here. So if you're looking to see what's machining where, this is a quick and easy way to do it. And then the order of that machining is controlled by one variable inside of rough. If we go to tool trajectory, if you switch from basic to advanced, the optimized by is set to fewer cutter changes. If you choose, you can select use shorter cutters. The priority will always be to use the shortest cutter, even if it means more tool changes. So if your focus is on just keeping the sturdier tool in there, this would be the option to use. So multi-cutter roughing, not a lot to it, but super useful. And it works in conjunction with the next item we're going to look at, which is automatic pre-drilling, because these options can work together. Let's take a look. Automatic pre-drill is brand new in version 2024. Some roughing cutters are terrible at plunging. This forces the entry move to an angled ramp, and for some tooling, this will shorten the life in addition to taking just longer to cut. Having the ability to drill a start hole in the optimum position will solve this problem. Automatic drill and roughing can do this utilizing up to 3 separate tools in addition to the roughing tool itself. Some things to consider. For our entry motions, we need to make sure that it is always set to no plunge. There are some instances where drilling is not needed. The tool can enter off the part, so it's no longer needed. Depending on the tool you use for the drilling, if you decide to use a normal drill, the tip of that tool can leave an angled stock volume amount that prevents that from doing any plunge motions that would allow the final layer to be machined. So, something to be considered when you're setting that up. We can do a final milling helical motion to remove that tip and get the full depth machining. When the drill cycle is set to first, the drilling will happen first unless the selector drill cannot reach depth without roughing happening first. The system is smart enough to sort this out. When drilling, the hole has got to be bigger than the selected cutter. It cannot be size for size. And the drilled hole depth or bottom is determined by the surface offset. This will prevent machining into the surface as well as give control. Let's look at it in a file. Alright, let's head back to our multi-cutter file we started here. And we're actually going to use this to show the next step. So we'll edit this procedure. And again, these two tools can work together, both the multi-cutter and the automatic pre-drill. So we're going to leave the multi-cutter turned on, but we're going to come up here to entry and endpoint. We're going to switch this to no plunge. First thing we got to do. And then we're going to set our pre-drill operations here. We're going to switch that from none to by cycle. Then right underneath it where it says drilling cycle, we're going to hit define cycle. Now, for those of you familiar with auto drill, this is going to look very similar, except the top and the bottom is determined for you. The number of cycles we want is right here. We're going to start with 1. I'm going to pick the cutter. We're just going to do a drill. And we're going to do a deep hole peck. Our increment is 1. Our top is stock top. The bottom is BT. We can pretty much, all this should be pretty standard here. So just like a cycle in auto drill, other than the cycles listed here are less. The only ones listed are relevant to actually doing the pre-drill cycle, and that's it. So let's green check this, and again, all we're going to do is calculate. Nothing fancy here. Now if I divide this out by tool, we can see our first cutter, our first cutter right here is our drill. It's going and found the areas it needs to move that material out. It's drilling them first, and then it's machining from there, each layer. So these two techniques work together. Now, let's look at this a little closer. In here, one thing you'll notice, I have drill holes first checked. This doesn't have to happen, but what will happen is, assuming I have this checked, it will drill where needed, long as the tool can reach first. If the tool cannot reach full depth, a layer will be machined before it comes in, tries to drill that area. So One little thing to keep in mind. And then let's look at the actual stock result here. I want you guys to see what this looks like. So you can see we have material being left in the bottom of this pocket, the bottom of this one, and the bottom of this one, and it shows it best right here. The shape of that drill is leaving material on the bottom, and because we have set to no plunge, it cannot machine that final layer without violating that rule. So something to keep in mind, and you can see it's in each of these pockets. So what we can do, there are tools to handle this. When you're in here setting this up, we go to entry and endpoints, drill cycle, define cycle. Number of cycles, we can set this to 2. So couple of options. First, we could have a drill that is a flat drill. We could machine the bottom flat. So depending on the depth would affect your selected tool there. In this case, we're going to go ahead and say a long 10 millimeter. For the drill cycle, we're going to pick the helical profile. The hole diameter, I do have to type this in. This is going to be whatever my previous drill was that I opened it up to. In this case, it's 12.7. Down step 1. And all of that should work. So now we'll go ahead and calculate. All right, let's look at the stock again this time. So this time, if we look at each of these pockets, we are machining all the way down to that final layer, and it's because we moved all of the stock out on that pre-drill hole. So now the cutter is able to plunge and fully remove all that material. And when we look at it in the simulator, we can watch this work. You can see it's done our drill. It's done the helical. We'll speed this up. And you'll notice that third pocket over there it's going to do later because it can't reach. So it's going to come back and do that after it's removed some of those layers. It's smart enough to figure that out for us. There it is doing that hole. And then again, because we're no plunge, it's only using that hole to get started. Let me switch this show for you guys so you can see it. Based on tool here. Now, we have machined all the way out, and it drilled this hole last because it knew that that was going to be a problem for the tool reach. So really smart tool, very useful, and both of these options work together. Now, let's look at this on a little more complicated part and how some ways to template this a little, because a lot of times we hear, I can't template this, my parts are too different. You can almost always template something. It's a matter of how you set up and the end goal. When you template, it does not have to accomplish machining the entire part. The idea is to do the least amount of programming and get it to the machine as quick as possible. So let's look at some ways to set this up. All right, so we'll start with this part here. We've got a cavity here, and we're going to just look at file setup a little bit. I'll show you my sets here, and these are all just something you can set up however you'd like. In my case, my default NC file always has a part set, always. When you do these, you can make them, you can assign them by criteria. There's a lot of ways to do this. You can assign it manually. In my case, it's set up, and I have a fixture set as well. So all these are automatic. One other thing I like to do is I'll turn on my part, and I will hide everything that is not parting line. and then I will assign it to a parting set. So it's easy to quickly grab just that part detail, everything other than the outside inside of the part. So something that I like to have for programming. And then the only other thing I'll include a lot of times is a covers set that includes cap faces and things like that. So having that set up, let's look at just a basic template here. So should I have a template that has a combination of both the automatic pre-drill, so in this case it's set up, I have a center drill, a drill, and a 1-inch insert. And then for my roughing, my cutters, I have 3 cutters that are 1-inch inserts. Now, what this is doing, I have safe milling on. So this is automatic. I don't have to pick this because the part's defined. The part surfaces are selected by criteria, and they are selecting the parting set. So all of this is automatic. For my boundary, I am selecting that by criteria. I'm saying outer only. And again, having that set predefined makes it really easy to grab this. So basically, I just apply this template, and right off the back, my part, my fixture, my stock, and the first bits of removing the stock material from the part are done and ready to go. So I would bounce over to the next file while this is calculating, get started on the next part. It's a really fast, efficient way to get started and get things going to the machine. Now, we would think this won't work on anything else in some cases. Well, if we go to the opposite half, this is a very different part. I can again come over here, go to the template, apply that exact same template, even though it is the other half, and execute. We'll let that run, and then we'll come on back. Now, if we look at this one, while that other one's thinking, let's go ahead and simulate this. All right, so we'll start running this so we can see that it's machining down the first layers here. As far as that can reach. There's our third tool. There's our drill. So that's going ahead and it's reached down, it's moved a lot of that material out so that my tooling can actually reach to clear that area out. So now we'll continue. It's reaching as far as it can until it has to stop. Now it continues machining now that that material is cleared out. So this one procedure has done multiple roughing insert tools, and it has drilled and milled to clear start holes for all of those. So I haven't plunged the tool at all. And then this all works going right over to another file. So same template, same approach, very quick programming. Milling that hole out. So we see second tool, third tool. So in this case, this one procedure again has done drilling and milling with multiple tool lengths. So taking just a little time to organize our work and set up a file can go a long way. And the other thing we should consider, this tool is using a 1-inch insert. I could have several of these procedures and they can just be different tooling. So maybe I start with a 1-inch, go down to a 12 millimeter, go down to a 6 millimeter, and then if there's nothing to cut, it won't cut it. So some really nice options in here on ways to efficiently and quickly remove this material. Last thing we'll look at here is the Connect site and how to log a ticket, the best way to reach out to us. When we get here, it will ask you to register or sign in. I have already registered, and if you have not, go ahead and get signed up. Any trouble at all, reach out to us at support. Once signed in, you can go ahead and click on support cases. And then once you're in here, we can go ahead and click on new case. We'll give this a title, test ticket for webinar. We can select our priority and we can say it is a medium priority and say sending NC file for help. We'll just pick something. The more details you provide, the better off it is. Once we've put this in, we can go ahead and check out our files here. If we want, we can select and we can go ahead and grab an NC file and hit open and upload. This is a really good way to share files and get things to us quickly so we can check it as soon as possible. All right, that'll be it for today, guys. I really appreciate you taking the time to check this out. Hopefully there's something in here you guys can find useful to your workflow, and we'll get to questions next. Thanks.